In this video, I'm going to be talking about the development of my vacuum-based filter, starting with the biasing section of the filter. This section is necessary because, as you may remember, vacuum tubes require close to a minimum of about 12 volts between the plate and the cathode in order for them to conduct in a way that would suit my needs. So I started off with a very basic 2 op-amp configuration with the input signal going to the non-inverting input of each op-amp, and then a negative bias going to the inverting input of one op-amp, and a positive bias going to the inverting input of the other op-amp, which I would then take the bias voltages from just the outputs of each op-amp. I then developed it slightly further because there were issues with this when I tested it in Volstad. And it was very similar, but each op-amp then had a configuration of 3 resistors running around it, including 2 10K resistors and a 1K resistor. And this functioned a lot better. However, I was still using a positive bias and a negative bias from the voltage rails. And ideally, I wanted to be using just a single voltage input because it would just make it slightly easier to work with. Because if I needed to adjust the bias input, so let's say I needed to use a trim pot just to slightly reduce the voltage, it would be a lot easier to keep it centered if I was only having to deal with one voltage input. So I used a final schematic that was very similar to the one on the diode filter by Moritz Klein, which you may recognize from other videos I've done. And this one worked the best out of all of the circuits, and it gave me a very large biasing range for the voltages that I was working with. Now, onto the actual vacuum tube ladder. The way I've connected all of these is very similar again to the diode ladder. So the plate of the first triode is connected to the positive bias. Then the cathode is connected to the plate of the second triode, and that continues down the whole ladder until you reach the final triode, which is connected to the negative bias. And at the junction where the plate and the cathodes meet, there is a capacitor which is detached and going to ground. I then have a secondary power rail which connects the heaters on all of the vacuum tubes to allow for very easy and neat control of all of the heaters, which are also connected to ground to allow their correct function. Then for controlling the actual resistance of the vacuum tubes, because I chose to have a fixed bias that couldn't change, I created, and this was just a little sort of test just to see if this would work, which I did go on to develop a bit further. I connected the I connected the grids of all the triodes together and had them going to a voltage input, which would allow me to change the voltage on the grids and therefore increasing the impedance between a current flowing, which would then increase the effective resistance and therefore filtering of the circuit. So here you can see I've developed the circuit slightly further. The first version, I added a large voltage divider and buffered the whole signal before sending it through the diode, as well as introducing another control voltage input. And then in the final one, which I used in the final schematic, it resembles the first schematic slightly more. However, it now has a 100K going between the inverting input and the output, as well as the 12-volt control voltage is now on the non-inverting input, whereas on this one it was going to the inverting input. Then moving on to the input stage, I used the first stage of a cascade filter, so I'd be able to introduce the resonance in the same way as I had on my hybrid filter of the ladder and cascade filter. And then the output stage, that was again very similar to the one of the diode filter, as I didn't need major reworks to this original circuit. And then for the resonance path, what I planned to do was have it similar to that of the cascade filters, but so I could switch how many diodes or clipping diodes there were, so I could, in essence, control how much distortion it would have. So here where I would have the amplitude, and we'll set this as 0 volts. And this is the base oscillation for the resonance. If I had no clipping diodes in, that's how it would look. Then when I introduce the first set, I'd get something looking slightly more like this. Then the second set would clip the resonance even further, leaving something more like this. Which would almost make it a square wave oscillation just based off of how it's been clipped. However, they're not quite the same. The other thing I quickly designed was just a filter switching system. So the way I planned on actually constructing the filter was I'd have two separate ladder filters. One would be configured as a high pass and the other would be configured as a low pass. This is because when you use a single ladder filter as a band pass filter, you decrease the order because you're having to use some of the diodes for the high pass and some of them for the low pass. And I ideally wanted to be able to have it all at a third order filter. So the easiest way to do that was to actually just use two separate filters, which were designated specific roles, and then have a series parallel switch. And these two switches are the same as each other. I only laid them out slightly differently because it was then easier to understand what was happening with the series parallel switch. But for the most part, that is the whole development of this specific part of the filter. In the next video, I'll show you the full final schematic for the vacuum tube filter and explain why I eventually decided not to use it in the circuit.